In this video, we will explain separation of variables. And the idea is to extend those differential equations for which we have a general solution. Let me just remind you that if we have something like dy dt equal k times y, then k is a constant, then the general solution is y equal to c1 e to the kt. And if we have something like dy dt equal to a function in terms of t, if the y is not there, then the general solution would be like f of t plus a constant, where we need to find an antiderivative, right? The antiderivative of little f of t is capital F of t. Then for this technique, we need to compute one antiderivative. We are going to see some other families in which we can find a general solution, and is this. We are going to write something like dy dt, and we are going to assume that here we have an expression like this in terms of y and t, but we say that this can be solved with separation of variables if, when we pretend that we can split this dy dt as a fraction, then we can write this as dy and an expression here in terms of y equal to, let's say, another expression here in terms of t times dt. Then when we can achieve this, when we can rewrite this differential equation like that, after pretending that we can split dy over dt as a fraction of dy and dt, if we can separate it like this, then we have a separation of variables. Let me do an example. Let's suppose that we have dy dt, but nicer. Let's suppose that we have dy dt equal y times t plus sine of y times t. Notice that here we can't just write it as dy dt equal to t times y plus sine of y, and then I can write like dy over y plus sine of y equal to t times dt. Then in principle, this differential equation can be solved by separation of variables, because I have been able to split the differential equation in two parts. This part doesn't have a t, and this part doesn't have a y. Let me do another example. If we have dy dt equal y plus t, notice that here it doesn't matter how hard we try, there is no way to split this into two ways. Like if I do y plus t over dt, then this part doesn't have a y, but this part has a t. Then this differential equation cannot be solved, let's say, cannot be solved using separation of variables. This one you can do by separation of variables. Let me do another one. Let's suppose that we have dy dt equal 2 plus 3y squared. Can we solve this by separation of variables? And in this case, we can write this like this times 1, and then we can rewrite it as dy equal 2 plus 3y squared dt, and then I can separate it like this, dy over 2 plus 3y squared equal to dt. You see, I have accomplished my mission. I wanted to have on the right hand side no y's or dy's, and on the left hand side no t's or dt's. Then this can be solved by separation of variables. Then let's see how to find the general solution. And let me just tell you that the tools that you need, we need to do two antiderivatives, and we need to do some algebra. Okay, let me work an example, and then we will explain the general what to do in general. We have, let's do this problem, dy dt equal 2 minus 3y, and just to practice, let's suppose that we want to solve y of 0 equal negative 1. Then let's separate the variables. We can see that this can be written as dy over 2 minus 3y equal to dt. How do we solve the differential equation? The tool says we need to do two antiderivatives. Then essentially what we do is we integrate on the left and we integrate on the right. These are the two antiderivatives. This antiderivative is easy. It's just t, and we usually write a constant here. And for this antiderivative, I'm going to do substitution. I'm going to remind you that we have du over u. This is natural log of absolute value of u. Right? But then this doesn't look like that, but then I can do a substitution. If I want to do dy over 2 minus 3y, if we want to do this integral, I can do u equal 2 minus 3y. Then what is the u? The u dy is negative 3. That means that du is negative 3 dy. Let's see if I can replace everything. The dy can be replaced with negative 1/3 of the u, and this is just u. And that means that this integral and this antiderivative is just negative 1/3 natural log of u. That means that this integral is just negative 1/3 natural log of t3 minus 3y, and I have that this is t plus c1. Notice that I have done the two antiderivatives. Why did I say that we have to do some algebra? Because here there are no derivatives. This is not a differential equation, but we have to solve for y. How do we solve for y? Then this is the part of the algebra. Let's multiply by negative 3, and then we get natural log of 2 minus 3y equal to negative 3t minus 3c1. How do we solve for the y? The y is inside a natural log. Then what do we have to do? We have to exponentiate, right? When we do e to this power and e to this power, we get, let's say when we do e to this power and e to this, we get that absolute value of 2 minus 3y is equal to e to the negative 3t minus 3c1. Right? But let's use a little bit of property of the exponent. This is e to the negative 3c1 times e to the negative 3t. But when we have an equation like this, like absolute value of y equal 4, what is the solution of something like this? The solution of something like this is you can break the absolute value, but then you end up with a plus or minus. Then here we have that 2 minus 3y is plus or minus e to the negative 3c1 times e to the negative 3t. So we can solve for y. Let's see what we have. We have that 2 minus plus e to the negative 3c1 times e to the negative 3t is equal to 3y, and therefore y is equal to 2 minus plus e to the negative 3c1 times e to the negative 3t over 3. But a better way to write this, notice that, is to replace this plus or minus e to the negative 3c1. We can just replace it with a constant, because when c1 is any number, e to the any number is any positive number, but you are considering plus or minus, then you have that we can write the general solution like 2 plus another constant, let's say c, times e to the negative 3t over 3. This is the general solution of this differential equation. What do we have to do in general? Let's try to see what we did. We have to do two antiderivatives and do some algebra. In general, when we have the expression like g of y times dy equal to h of t dt, then we have to do the two antiderivatives, right? And usually we just write, we have a capital G of y equal to an antiderivative here, and we just write one constant here, plus c1. And then what we do is we can just, this is the two antiderivatives, and the algebra is because we have to solve for y. Right? Then we have to do some algebra to get into here. I just realized that I forgot to find the initial condition. How do we find the initial condition? Notice that once we have the general solution, what do? Anytime I see the y, I replace it with y of 0, and anytime I see that t, I replace it with t sub 0. Then in this case we have that 2 plus c times e to the 0 over 3. We want this to be equal to -1, and that means that 2 plus c is equal to -3, and that means that c is equal to -5. And therefore, the solution of the initial value problem is y equal 2 minus 5 times e to the -3t over 3. Let me do one last example, and then we'll stop here. Let's suppose that I want to solve this differential equation, dy dt equal 2t plus 1 over y squared. And let's suppose that we want y of 1 equal -2. Then we have to separate the variables. How do we separate the variables? We have that y squared dy, right, equal to 2t plus 1 dt. Notice that the dy dt got separated, and here we have no t's or dt's, no y's or dys. Then we do the two antiderivatives. What is the antiderivative of y squared? The antiderivative is y cubed over 3. And what is the antiderivative of 2t plus 1 is t squared plus t. And we usually write only one constant here. If you want, you can solve for the constant here. How do we solve for the constant? When we replace t by t sub 0, I get that -2 cubed over 3. I want that to be equal to 1 plus the constant. What is the constant then? The constant is C1 equal to -8/3 minus 2. What is this? This is -8 minus 6 over 3. This is -14/3. Then we have that the solution is y cubed over 3 equal to t squared plus t plus c1. If I want to compute the general solution, I will have to solve for y from here. But since I wanted to compute an initial value problem, I decided to find the c here. And how do I solve for y? I can just multiply by 3. But c1 is -14/3. Then how to solve for y? I just multiply by 3. And then I get y cubed equal to 3t squared plus 3t minus 14. And then I can solve for y by raising to the 1/3. Remember that there are two components that are doing two antiderivatives, and then you need to do some algebra to solve for y. I think I would like to stop here.